So it only remains for me to introduce Ian, who of course will be already known to very many of you. Even those of you who haven't met Ian before, I'm sure will have seen his nature notes in the Gazette, which I always read with very great enjoyment. So Ian's background is in medicine, so he's very well equipped to give this talk tonight, both from the botanical point of view, but also from the medical point of view. He trained many years ago in Cardiff, which was where he met his now partner Hugh. Then he had a succession of interesting medical postings, including what he describes as a James Herriot-like, but for humans, kind of posting in the North York Moors, a rural GP. Eventually, he trained as a radiologist in Leeds, I believe, Ian, and then ended up at Airedale, where he spent a very happy 21 years doing consultant radiology. He's now retired, but that has afforded him the opportunity to indulge an interest from his youth, which is botany, which I understand was something that his A-level biology teacher encouraged. We can all give thanks, I think, to those amazing teachers who, at various points in our school career, encouraged this or that particular interest. Ian's always enjoyed teaching, and so I think during retirement he's been making the most of these opportunities, you know, via things like nature notes, via talks like this, and talks to other organisations, to give botanically themed talks and extend his own interests and knowledge. Okay, so tonight's talk is called Plants, Pills and Potions, the story of how plants became today's medicines. I'm very much looking forward to it. Over to you, Ian.
Thanks very much indeed, Helen. That's thanks very much indeed. And good evening, everyone. In a moment, I'll be sharing my screen so you can see my PowerPoint. But it's lovely for us all to be together again, even if it has to be via the ether of the internet. So let me just share my screen and let me just start the show in just 2 ticks. So as Helen said, I want to talk to you about 2 subjects very close to my to my heart, that of both plants and also medicine, and thereby tell you the story of how plants became today's medicines. Now, it's a truly fascinating subject, and for me, it combines 40 very happy years, both studying and practicing medicine, along with my love of all things botanical. It's not just a fascinating subject, it's also vast. So all we can really do is just dip our toe in the water. But along the way, hopefully we're going to have a little bit of botany, some popular science, also a bit of geography and history, but above all, some interesting stories. Now, I'm not a great raconteur like Peter Ustinov, but I'm hoping that you're going to be entertained. So to whet your appetite, we're going to find out how Charles II and President Eisenhower both popularized plant-based medicine, why Levenshall in Cumbria saved its yew clippings to help treat patients with cancer, what the Queen Mother's favourite drink, Dubonnet, or perhaps I should say Dubonnet and gin, has to do with treating and preventing malaria, and finally how a lorry load of mouldy hay started the search for what is the most popularly prescribed anticoagulant or blood thinning agent. But before I go too far, I just have to deal with the elephant in the room. And whenever you mention medicine and plants, there are immediately 2 camps, herbal medicine on one side and modern day pharmaceuticals on the other. But for me, really, they're on the same spectrum, because a lot of modern day pharmaceuticals have their origins in early herbal remedies. And if I'd been a doctor in the 15th to the 19th century, most of the drugs I would have used would have been based on drugs. And even in 2020, 1 in 3 of our drugs are made or originate from plants. And it's also interesting to bear in mind, we've only actually ever looked at 10 to 20% of the plant species in the world. There's another 80 to 90% plants there, which we could investigate further for biological activity. So why do plants have this wonderful array of chemicals which us humans can use as drugs? Well, the answer isn't for our benefit, it's for theirs. If you're an animal and you're in danger, you can easily move, you can move away from that danger, or if you're under attack, move away. But plants are literally rooted to the spot, and they're under attack from a number of quarters. Herbivores, insects, in particular the larval form, a whole array of pathogens such as bacteria, fungi, viruses, and also from other plants. This is the coffee plant, and it's not just the coffee bean that contains caffeine, it's also the leaves. And as the leaves fall down to the soil, the caffeine, which is an alkaloid, gets incorporated into the soil, and it inhibits other plants growing nearby. Now, we can quite easily see the mechanical defense, which is aimed against herbivores, in particular the spines from spear thistle, the thorns on gorse, the prickles on brambles, and the stinging hairs from stinging nettles. But what we don't see, and is arguably even more important, is the hidden chemical defense. And there's a great array of chemicals. I don't really want you to pay any attention to the chemical structures. I'm not going to show you any more chemical structures, or even really the names, except it reminds me to tell you there are actually thousands of chemicals that plants produce, and some chemicals are only produced by a few species. As I said a minute or two ago, 1 in 3 of our drugs today are still produced or originate in plants, and a lot of them are chemically synthesized, but a number of drugs, such as digoxin, you can see just down bottom right, the molecule is just so large and complex, rather than synthesize it ourselves, we ask the plant to do all the hard work, and we then just harvest the drug from the plant. So how have we discovered and used these chemicals? Now, for that, we need to go back in time. The history of medicine is, again, a vast subject. I'm just going to pick out one particular person who I think is quite important prior to the 15th century. And it's probably a person you may not have heard of. And that's, going back in time, Dioscorides. Now, he was a doctor, a Greek doctor, working for the Roman army in the 1st century AD. And he wrote a very important book. He was both a doctor and a botanist, and it was called De Materia Medica. And he looked at well over 600 plants in the Mediterranean region. He described them so you could identify them, much like we have a flora today. But also, he then went on to explain how these could be made into drugs and from what diseases they could be used to treat, what diseases they could be used to treat. And this really was then copied and plagiarized for the next 1500 years. And there wasn't really that much advanced during this period of time until we get to the Renaissance. Now, the Renaissance isn't just about art and culture, it's also about science and medicine and coming together in universities. So scholars were brought together. And from this period onwards, there's a much faster advance in both science and medicine. A lot of these medical schools had botanical or gardens or physic gardens attached to them. The first 2 happened to be in Italy, Pisa, and the one in front of you, Padua. And you can see that, looking at the image on the left compared to the photograph on the right, hasn't changed that much in nearly 500 years. The UK was a little bit slower to follow on, but we had our first botanical garden in Oxford, attached to the medical school and university there. Then Chelsea's physics garden, Edinburgh, Kew, and Cambridge. And these are not just wonderful botanical gardens to wander around, they're actually scientific institutions. And I really recommend, if you're near any of these places, to pay a visit, because as you wander around, the storyboards are so full of information and facts for you to learn. Now, for every 2 steps forward, there's 1 step back. And that is with this chap here, Paracelsus, who actually was quite a well-known scientist in his day and did quite a lot of good things, but he was also a great believer in the doctrine of signatures. And that says that every plant was signed by God in some aspect of color, shape, or design to show which illness or condition it would cure. So that because walnuts look like brains, it was thought that you could use walnuts to treat brain diseases. Now, obviously, this is not scientifically correct in any way, but it's quite interesting that the doctrine of signatures actually gave us a lot of our common everyday plant names. And just I want to look at just three, which I think are quite interesting. The first one is eyebright, commonly found throughout the pastures and meadows and grasslands of in Wharfedale. It's a partial parasite, just like the yellow rattle, and it was thought to be useful to treat eye disease because the purple nectarine in the flower was thought to look similar to the engorged vessels in the inflamed conjunctiva. Lungwort, I suspect many of you actually may grow this in your garden, and this is thought to be useful to treat respiratory illnesses because the leaf looked like the shape of a lung, and even the dots on the leaf were thought to represent the airways or bronchi. Just before we leave this slide, a lot of plant names end in officinalis, and this means that it's been used as a medicine, not necessarily now, but at some time in the past. And last of all, toothwort, not uncommonly found in sort of damp woodland. I've seen up and down the sort of in the Wharf Valley. And as you can see, it doesn't contain any chlorophyll. Although it's not strictly a parasite, it's saprophytic, which means it survives off the dead material within the soil. And this, because of its flower shape, was thought to be useful to treat dental problems. So moving on to the last 2 centuries, the 19th and the 20th, there was a move from the botanical to the chemical approach. So we took the plant-based medicine, chemists analyzed it and found out their chemical structure. And from there, a lot of our plant-based medicines were then chemically synthesized. Sadly, botany and medicine have gone their own ways. The botanists have their flora, and doctors and the pharmacists have their pharmacopoeias. Although in Germany, I understand that pharmacy students actually are taught botany as part of their degree subject. And I think it could be quite nice if we had a few lectures in Britain for the pharmacy students and the medical students. So in the talk, with time limited, we're going to look at 6 drugs altogether, which are plant-based. The first 4 come from either herbal medicines from UK and Europe or traditional medicines from further overseas: aspirin, digoxin, morphine, and quinine. And the last 2 have come to the fore really in the 20th century. Warfarin was a chance discovery, and Taxol, which is a anti-cancer drug, was found by active search. And sadly, along the way, we're also going to see some colonial powers from Europe behaving badly, such as the Spanish, the Dutch, and the British. In the UK, we have very few dangerous animals, but we have lots of poisonous plants. And if somebody asked me for my top 4 most poisonous plants in the UK, they would be deadly nightshade, hemlock, monkshood, and digoxin. And 2 of these plants actually give rise to plant-based medicines, and therefore the difference between a poison and a medicine can sometimes just be literally the dose. Deadly nightshade gives us atropine, or contains atropine, and Venetian women would often put the juice of the berry in their eyes, thereby dilating the pupil. And in dilating the pupil, it also made them look more attractive. Belladonna, meaning beautiful woman. Socrates was famously killed by drinking a potion containing hemlock. And Shakespeare's Romeo killed himself thinking Juliet was dead using monkshood, or sometimes known as wolfbane. And despite being a very poisonous plant, it's actually grown in quite a large number of gardens. And finally, surprisingly, Foxglove, which we actually chose as our flower of Wharfedale earlier in the year. Many of you might think would be difficult to confuse Foxglove with any other plant, given its tall spike of wonderful pink flowers. But you've got to remember that foxgloves are biennial, and in the second year it has the flowers. In the first year, it's just a rosette. And you can see here the rosette of foxgloves and that of comfrey and many other plants as well look pretty similar. Now, as I said, this is going to be one of my 6 drugs I'm going to talk about. And the story starts with a chap called William Withering. Slope of water. He was a doctor working in Birmingham in the 18th century. He was also a botanist, a geologist, and a chemist. He's really my sort of man. I'm interested in all 4 of those things. He's also quite scholarly, and he was a member of the Lunar Society, so called because they held their meetings on full moon, because it was safer and easier to travel to the society meetings when it was a full moon, when you're traveling on horseback. Now, Withering was asked to see a patient who had dropsy, what we now would know as severe cardiac failure, swollen legs, swollen abdomen due to fluid around the liver and the bowel, short of breath, fatigue, and also as you look at the face there, he's off losing weight as well. And he couldn't really do anything to help this poor lady, and he said as much. But the family didn't give up hope. They asked for the help of a Shropshire herbalist who suggested regular herbal tea infusions. And much to Withering's surprise, she actually got better. So he sought out the herbalist and asked what was in her herbal tea, and she gave him a list of 20 different herbs. By experimentation, he eventually found it was the foxglove which had the active ingredient. And he then went on to publish a book, encouraged by his colleagues in the Lunar Society, which actually was in print for well over 100 years and describes how he uses the foxglove to treat dropsy and other conditions. Around this time, we were using our well-known purple foxglove we get in the UK, but for the last century or so, we've been using the woolly foxglove, which comes from Eastern Europe. Reason for this is that it contains digoxin, whereas our common purple foxglove contains digitoxin, and the digoxin is a safer drug. There's just one occasion when we had to revert back to our common foxglove. It was when the Second World War was on, Germany had invaded Eastern Europe, and therefore the woolly foxglove supply and therefore digoxin was cut off. So the government asked the Women's Institute to collect our native foxglove, and therefore it saved a lot of lives with people with heart disease. Even now, all these years later since Withering's discovery, we still don't know really how digoxin works, but it strengthens the heart muscle and it slows the heart rate. We don't use it that often for heart failure anymore, but we do use it for a very common condition called atrial fibrillation, which is a funny heart rhythm which affects almost 1 million people in the UK. The gardeners amongst you, you'll probably know that the Christmas rose, the oleander, and the lily of the valley are all poisonous, and they're poisonous because they contain digoxin-like chemicals, what we're commonly known as cardiac glycosides. Now, I want to stick with a drug which actually came to its fore in the UK in the mid-18th century, and that's aspirin. And the story involves its rise in popularity and use, its fall, and then its rise again. Now, it's something we've known about for a long time, and the Egyptians, the Romans, the Greeks all knew that willow bark was good for pain relief, joint problems, and also for fever. It was an analgesic, it was an anti-inflammatory, and also an antipyretic. But the person who gets all the credit is this chap here, who is Reverend Edward Stone, who was a vicar in Chipping Norton in Oxford, also a fellow of an Oxford college. He tasted the willow bark and it reminded him of cinchona bark. Now, we'll be talking about that a little bit later. That's also used to treat fevers. So he thought he would experiment with his parishioners. And this was really one of the earliest clinical trials carried out. We take clinical trials for granted these days and hear a lot about them on the news given the COVID pandemic. But Edward Stone and a few years later, William Withering were really the first ones to carry out clinical trials. So he ended up treating his parishioners with the willow bark over a 5-year period for agues, what we would now refer to as chills or fevers, and great success. And being a scholar from Oxford, he actually reported this in the journals of the day. And the willow bark he was referring to was the white willow. And if I just increase that in size, you can see that the underside of the leaf contains white silvery hairs, and when the wind blows, the tree appears as a sort of whitish green, which gives it its name. 60 years on from from Reverend Stone's paper, we actually isolate the active ingredient from willow bark, which is these yellow crystals, and it was named salicin after the willow tree, which its Latin name is salix. Even then, we knew it wasn't quite the whole story, and we know that salicin, once it was ingested into the body, was converted to a metabolite in the body called salicylic acid. And you can see again that the salicylic acid refers back again to the name of the willow tree. It's around this time that salicylic acid was also discovered by a Swiss pharmacist this time in this plant here. A beautiful plant, grows in the verge and hedge banks all around Wharfedale. That's meadowsweet. And something I like to tell people is that in the spring or in the early summer, if you crush the stalk, you get that wonderful smell of childhood, which I remember, germaline. It's also a member of the rose family. You get some feeling for it here with its 5 petals and multiple stamens. But it's actually the fruit which intrigues me. And if you look up close, it has that sort of curly appearance, which reminds me of those, the luxurious confectionery from the 1970s and 80s, the walnut whip. Now, throughout the second half of the 19th century, we started to make salicylic acid chemically rather than using willow bark. But the trouble with the salicylic acid is it was actually had a lot of side effects. And we still use salicylic acid, but we use it in treating viral warts and psoriasis. And if you think what it does to a viral wart, it's actually doing that to your stomach. So there's a demand for a safer drug. Bayer, who were a German dye manufacturer at this time, had a lot of spare chemists, and they wanted to enter the pharmaceutical industry. So it set them on a task trying to find a drug to produce. And they found by changing the salicylic acid into acetylated salicylic acid, it made a much safer drug. And 2 years later, they were able to launch Aspirin. Now, Aspirin isn't a chemical name, it's actually a trade name, a bit like we use Hoover for vacuum cleaners or Thermos for thermos flasks. And it's quite interesting where they got the name. Around the turn of the century, meadowsweet was known as Spirea ulmaria, not Filipendula ulmaria. So what they did was they took the A for aspirin, which gives us acetylated, and the spur from Spirea, echoing back to meadowsweet, and the iron is just a common suffix for drugs. Didn't take off immediately, but come the First World War, especially towards the end of the First World War, when we had the influenza pandemic, it was commonly known as Spanish flu, although it didn't start in Spain, it actually started in America. But it was the end of the First World War. There was a lot of censorship going on by the newspapers within North America and most of Europe, but not in Spain because it was neutral, and therefore the Spanish reported on the pandemic. That's why it got known as Spanish flu. Now, it didn't cure influenza, but it did relieve the symptoms of fever and headache. Then it continued its popularity throughout the first half of the 20th century, but halfway through, it was getting some concern, a bit like salicylic acid before it, that there were some side effects. And then in 1950, paracetamol was introduced. And this was both a painkiller and also it decreased fever as well, which is why we give Calpol syrup or paracetamol syrup to children to lower their temperature. And it is a safer drug in many ways than aspirin, although both aspirin and paracetamol have serious consequences if taken as an overdose. Then 10, 15 years later, another group of drugs were introduced, the non-steroidal anti-inflammatories. And many of you probably know about these, particular ibuprofen or Brufen. And these were painkillers and also anti-inflammatory. So these two sets of drugs, paracetamol and non-steroidal, did what aspirin did, i.e. is a painkiller, lowered the temperature, and also decreased inflammation, and probably more safely. So really, it almost looked at this stage as if aspirin might have been just a footnote in history, really. But except in the late 60s, someone noticed that aspirin prolonged the bleeding time. And if you look at the blood on the right-hand side, this is blood film, which is blood seen down a microscope. You've got the red blood cells carrying the oxygen, the white blood cells fighting infection, and the small purple dots are platelets. And these are important in clotting, and it was noted that aspirin decreased the thickness of the platelets. So I can remember as a medical student in the 70s and a junior doctor in the 80s, a lot of interest was put into this, looking at diseases which in particular where clotting was important, such as heart disease and stroke. And then in late 1980s and then the early 1990s, it was prescribed widely for people who've had a heart attack or those who had a stroke. And now it's actually used even with those who are at risk from having heart disease or stroke as well. And we also now use aspirin occasionally for people at increased risk of colon cancer, because we know it decreases the risk of that. Now, I want to stick with fever, which is what aspirin was famous for initially, and talk about agues, marsh fever, bad air, and keeping the pink bits pink. And it's the British Commonwealth map on the right-hand side. I wonder if any of you have any ideas about what I'm talking about. And it's actually malaria, which affects 50% of the world population. Well, sorry, it's the 50% of the world population is at risk. 200 million people are infected each year, and of those, 400,000 die each year, mostly in Africa, and very, very sadly, often it's children as well. If you look at you can see Europe doesn't have any cases, but there's about 10 to 15,000 cases of malaria treated in the UK from people returning from overseas. But that wasn't the case going back in time, going back to the 14th and 19th centuries, when there was a condition called marsh fever, which was malaria throughout the UK, but it was particularly common around the marshes of Essex and Kent and London, and also the fens and the Wash around South Lincolnshire as well. And it was all put down to the bad air from the marshes, which is where we get the name malaria from. Because bad air in Italian is malaria, and that gives us our name of the disease, malaria. But they didn't know what we know today, and that is the actual disease is actually transmitted by the mosquito, and the actual infection is a very small parasite called Plasmodium. And this is another blood film, a blood seen down the microscope, and you can see the red blood cells, and you can see those small purple dots and a little squiggle, and that's the Plasmodium parasite. So malaria was very common in Europe, including particularly around London, Essex and Kent. And therefore, there was a lot of interest taken when the Spanish invaded and colonized South America. In particular, we were in a population in Peru and Bolivia who were found to use this bark from this tree, the cinchona tree, also known as the fever tree, to treat fevers. Now, they probably weren't actually treating malaria because malaria didn't exist in South America until the Europeans arrived. But what the Peruvians and the Bolivians did, they would strip the bark. They would then dry the bark before making it into a sweet tonic. So it wasn't Schweppes that invented tonic. And the reason they did this is that the quinine, which is the active ingredient in the cinchona bark, is actually very bitter. It's a very bitter tasting alkaloid. It was a Jesuit priest who came across this, and Rome, like London, had problems with malaria, and they took it back to Rome in the mid-17th century, where it successfully treated malaria, and it was known as either Peruvian or Jesuit bark. Now, we were a bit slower taking off this idea in the UK, and Oliver Cromwell, who had several bouts of malaria during his life and probably actually died of complications of it in the end, refused to have anything to do with it because it came from Rome. Charles II, on the other hand, was happy to be treated with cinchona bark by his physician, Dr. Talbot, and made a good recovery. And thereby, he actually popularized the use of quinine within London and society generally. Dr. Talbot, his physician, went on to make a fortune also treating the King of France and the Queen of Spain. Initially, the production was small scale, but it gradually increased, and really you started to get to quite devastation of quite large areas within Peru and Bolivia, a bit like the attack on the Amazonian rainforest today, really, and deforestation. And quite naturally, Peru and Bolivia were quite keen to control this. After all, it was one of their natural resources, and they outlawed the exportation of seeds and saplings overseas, except the Dutch managed to steal some seeds, and in the mid-19th century took them to East Indies, to Java, where they grew the cinchona tree to make quinine there. The British also did the same a few years later, taking seeds initially to Kew, where trees were grown, then further seeds and saplings were taken to India and grown in the botanical gardens there, and then commercially. It was transported around India by railway, and then also by using the postal system as well. And it's also where the British got their or love, I should say, for gin and tonic, because the gin took away the sort of bitter taste of the quinine. Now, I did promise you at the start that I'd tell you about the Queen Mother's favourite drink, Dubonnet, or maybe that should be Dubonnet and gin. I think she drinks it a third gin and 2/3 Dubonnet. What that has to do with treating and preventing malaria. And it's actually all to do with the French. The French had a big problem with their legionnaires. They were given quinine, but they weren't very keen on drinking it when they're on service in North Africa, where they were at risk for malaria. So the French government had a competition to see if someone can invent a drink to take with the quinine, which would encourage the legionnaires to take it and take away the bitter taste. And it was won by Joseph Dubonnet. And I suppose he became the first, so Dubonnet became the first designer drink. Now, it did very well, quinine and various other quinine-like drugs, but come the mid part of the 20th century, there was increasing drug resistance, a bit like we have drug resistance to antibiotics today. So the call went out to have an alternative drug. And the answer came from a very unusual quarter. It was the Chinese army, who had a research program going on looking for an alternative anti-malarials. I suspect they had secret desires on other Southeast Asian countries, which had increased, which there was a great risk of malaria. And they looked at thousands of plants and found only really one which was effective, and this is the sweet wormwood. And from this, they produced a drug called artemisinin, taken from the generic name of sweet wormwood. It's also grown by horticulturists in beds, has a very attractive foliage. And if the sweet wormwood looks familiar to you, and maybe the name sounds familiar as well, there are actually two native species. Well, actually not native, they're ancient introductions into the UK, which also come from this genus. First one is mugwort, very common plant, found along our grass verges and arable fields, and also in rough waste ground. And because it doesn't contain a lovely flower like the meadowsweet, it often it doesn't get noticed. And the other one is wormwood, commonly grown in gardens as well. And as its name implies, abyssinthian, is actually used to flavor the drink absinthe. I think we've heard enough about fever. I want to talk to you about pain and about pain relief, which goes back to antiquity. Now, this drug is so important, it's actually part of the crest of the Royal College of Anaesthetists. I'll just blow this up for you, see if you can see it. It's the opium poppy. We often talk about opium and the drugs that come from opium, the opiates, but what actually is opium? Well, the traditional way to make it would be at its green state. This is, as seen in the photograph there, before it dries out and it releases its seeds. In the evening, you would make lacerations of the seed head, as you can see here, and then this milky latex would come out. It would be left overnight, and then come the morning, it would be scraped off, further sort of desiccated, and this would be opium resin. And it contains a large number of chemicals and alkaloids, but in particular, the important one we're talking about is actually morphine. It contains 14% morphine. Victorians are very keen on it. They would often dissolve it in alcohol, and it was then known as laudanum. And Queen Victoria took it quite regularly during childbirth. Morphine was also probably the first chemical to be extracted from a plant. And because of its effect on the brain, it was named after the Greek god of dreams, Morpheus, which gives us morphine. And also, it can quite easily be manipulated into dimorphine, and both morphine and dimorphine are actively used drugs. And you'll probably know it more by its street name of heroin. But there's two sides to any story. It's a wonderful painkiller, as I've said already, but also a cause of so much misery, addiction, criminality, social deprivation, and even war. And I'm afraid we're back to the British again with the Opium Wars in the mid part of the 19th century. Now, the reason for these wars were complex, but the sort of straw that broke the camel's back, or the Chinese back, was when the British started pushing opium, which was grown in India, into China. And come the second half of the 19th century, 25% of the male population in China were addicted to opium. Quite naturally, the Chinese retaliated. It's not a war they won. And as part of the treaty to finish the first part of the war, the first war, they had to give Hong Kong to the UK, and it was actually the British government became a UK overseas territory between 1841 and 1997 when we gave it back to China. Morphine, like digoxin, is still produced from the opium poppy. It's produced traditionally in India, but also it's produced commercially, but also in Turkey and Tasmania, where they have large fields of it, and they just harvest the green stage of the capsule and the stem, and they extract the opium from that. I've actually even seen opium fields growing in Lincolnshire, the fields of Lincolnshire as well. So we talked about herbal and traditional medicines, and it's time to talk about a couple of drugs which were actually first came on the market in the 20th century. And what lots of people don't often realize is that many scientific and medical discoveries actually happen by chance and an inquisitive mind, a bit like Alexander Fleming and penicillin. So it's time for the story about that lorry of moldy hay I told you about. In the 1920s, in the northern part of the United States of America and also Canada, there's a lot of wet summers. And this gave, and also at the same time, there was a bleeding disorder of cattle. So they would bleed spontaneously, and also after simple surgical procedures like having their horns removed or castration. Two local vets investigated, and they put it down to the moldy hay. And they thought it was due to the yellow sweet clover, or as we know in the UK, red millet. The yellow sweet clover was a very common fodder plant in the United States, and they called it sweet clover disease. They encouraged the farmers not to use the moldy hay, but to use other alternative fodder crops, But either farmers didn't believe them, or this is the time of the Great American Depression. So money was very, very short. And so therefore, they carried on using the moldy hay. They didn't buy in fodder from elsewhere. And the disease continued until one farmer had had enough. It was 1933. His prize bull had died, hemorrhaged to death. And so he had enough. So he loaded up his lorry with moldy hay and also took a bucket of unclotted blood, should have been clotted, from the bull, and drove 200 miles to the Wisconsin Agricultural Research Unit and handed these over to Dr. Carl Paul Link and his colleagues and students. And they worked on it over a 7-year period, trying to find out what was the cause of this bleeding disorder. And they found it was the coumarin, which was in the yellow sweet clover, under the action of the microbes in the moldy hay, which produced the active drug dicuramol, and that caused the bleeding disease in cattle. And it was quite a short trip then to produce warfarin. And warfarin, a bit like aspirin, has an interesting derivation of its name. The main supporters of the research unit was the Wisconsin Alumni Research Foundation. So that gives us the Warf, and the Arin is just quite a common suffix to drugs. Coming full circle, it's the coumarin which gives the red millet or the sweet yellow clover its smell, but it also gives the smell to quite common and well-known British flowers, the sweet woodruff and the sweet vernal grass. They both contain coumarin as well. So rat poison initially, but this thought far too dangerous for human use, until in 1951, a young army recruit tried to commit suicide taking rat poison, but he survived using the antidote vitamin K. Although these days we would probably also use fresh frozen plasma. So if you give blood, or if you've given blood in the past, thank you very much indeed. And it was then marketed as an anticoagulant for human use. But, you know, a lot of people wouldn't be that interested in taking rat poison. So it took a famous person to be treated with it, a bit like Charles II and quinine, and that was President Eisenhower. In the mid-1950s, he had a heart attack, and his doctors treated him with warfarin to thin the blood, which would help with the clotting of his coronary arteries. We don't use warfarin for that anymore. We'd use aspirin, as I said a bit earlier, but it is something we still use quite a lot, quite frequently, warfarin. We use it for clots in the lung, pulmonary emboli, clots in the leg, DVTs, and also, like digoxin, we also use it for atrial fibrillation. Now, for our very last plant, we're really going back to tree bark again. In the second half of the 20th century, there's a great we were keen to find a cure for cancer. And in the late 1950s and 1960s, the National Cancer Institute in the United States sent botanists out to collect samples from all around North America and also from further afield for potential sources of anti-cancer drugs, which would then bring back to the laboratory to be looked at in more detail. They looked at thousands, perhaps 12,000 plant species altogether, but they only had 2 leads. One of those didn't really come to that much, really. But the one I'm going to talk about was very important, or is very important, I should say. And its story starts in 1962. Botanists went to the Washington state in the northwest part of the United States, and they went to the beautiful Gifford-Pinchot National Forest collecting botanical samples. And one of them they brought back was the bark from this tree, the Pacific yew. And in the laboratory, a couple of years later, it was then found that the extracts in this tree were toxic to living cells. And that was just the start of the process. It then took them another 7 years to actually isolate the chemical which was doing that. That was Taxol. And I'm going to call it Taxol because that's the trade name, and it's a bit easier to say and to remember as well. It took another 8 years to work out as a completely new way of treating cancer or dealing with cancer. And really, this is really quite exciting stuff by this stage, but there are problems. The concentration of the Taxol was very low. It's only present in the bark And it took the bark from 6 trees to treat just 1 patient. And harvesting the bark killed the tree. So the corps went out to find a yew tree species which contained the chemical or something similar in the leaves, but not just the bark. And the answer was quite close to home. It was the European yew, where they found a very similar molecule, which could be, with a little bit of modification, made into the drug Taxol. The yew tree is a lovely tree. It's one of my favorites. You often find it growing in churchyards, partly because churchyards are built, or churches, I should say, are built at sites of previous pagan worship, and pagan worship often at sites of where the yew trees are. Taxos, which is the Latin name of yew, also comes from the Greek, from the bow taxon, because yew was used in the longbows in medieval times. And knowing that the plant is poisonous, it's also where we get our the word toxic from. Ornithologists out there might be thinking, well, how come birds can eat the berries then? Well, the answer is it's all poisonous apart from the red flesh of the berry. That's the averil. Even the seeds is poisonous, but that passes straight through the bird's gut. So having found that the European yew was going to be a good source of Taxol, the corps went out to places like Levenshall in Cumbria to collect their yew clippings from the topiary and send it in for processing. Now, that's not something we have to do anymore because we can chemically synthesize the drugs using a sort of a plant tissue culture. So Taxol, although not quite a golden bullet as such for cancer, has become a game changer, and is particularly used in treating ovarian and breast cancer, but also lung and pancreatic cancers. And to end on a sort of positive, upbeat note, I can think of at least 2 friends who have been treated, who had breast cancer and been treated very successfully with it using Taxol. So that's the end of the story. There's so much more I could have said. Thank you for listening. Keep safe and keep well. And I suppose it's time for any questions. Thanks very much indeed.
Thanks, and that's excellent. I'm not generally a great botanical fan, but when you put it like that, I'm definitely interested. That was wonderful. Thank you. And
well, yes. I do have an enthusiasm for plants. I'm not quite sure where it comes from. Well, it comes from my biology teacher, but yes, it's sort of I try to make it accessible to everybody rather than sort of make it too sort of twittery, if you know what I mean, and too many Latin names. Anyway.
Thank you. You've also played to a full house. We've had the full 100 connections that we've had capacity for. So
right, great.
Well done. Couple of questions, but there's room for more if anybody else wants to ask questions.
Best.
The first one you mentioned earlier about malaria being present sort of in the Essex marshes.
Yep.
If it's not there now, what happened to it? Did it?
That's an interesting question, really, because in a way, it's probably because of drainage of that. We've had better treatment of it as well, and sort of we've also actually had. We've actually tried to remove the mosquito as well, not totally successfully, but it's just gone of its own accord as well. A bit like sort of in a way with influenza, how it sort of the pandemic in 1919 it just stopped all of a sudden, really. I mean, people might ask also, how do we know it was malaria? But malaria, there's several forms of it, but often it has a sort of, it doesn't have a fever every day often. It often has a fever every 2 or 3 days. And we knew that from the reportings and the writings at the time, that this is what happened with this particular illness. And then for that reason, we thought, well, that's how we know it was malaria that was happening here. Because most infections would have a sort of a peak in temperature every day.
Okay, thank you. And the second question is, how much has Chinese medicine informed the development of modern drugs?
Well, quite a lot, really, because something I didn't have time to say, but artemisinin, which is the drug which was used for to treat malaria, they actually got that idea actually from a Chinese herbal which is from 200 BC. And the woman who actually discovered this and promoted it and produced artemisinin, I think it was 1972, but in 2015, her name was Dr. Yu Chu, was actually given the Nobel Prize for discovering it. So, and it has been used for other drugs as well. So And these days, as we start looking for, we're still looking for drugs from plants, and using old herbal remedies, using things like Chinese books on medicines, actually is actually quite a good source for starting looking for those drugs.
Great, thank you. Have there been any, I'm sure they'd be notorious, examples where adoption of plants as medicines has gone horribly wrong?
I can't think offhand. Obviously, lots of the drugs which were used in medieval times, the doctrine of signatures, that was obviously, there's lots of poisonous poisonous plants there. Really. I mean, and a lot of also, I mean, we spoke about digoxin, which was a very good drug, but the actual difference between actually being useful as a medicine and being useful as a but also called being a poison is actually quite narrow, really, and a lot of people end up getting sort of side effects from it, often yellow vision and various other things. So I can't think of any specific drug which gone wrong, but I'm sure there must be, because history of medicine is littered with drugs which haven't always gone well, really, or surgical procedures, etc.
Mm-hmm. And then a question which carries the "don't try this at home" warning: would we die if we ate a foxglove leaf?
Well, you would die if, well, the actual active, it's in the leaves where the drug is actually, well, the chemical digoxin is actually digoxin is. So my advice would not be to drink it. If you ate too many leaves, yes, you would die of it. Yes, so I don't know how many deaths there've been. There are occasional deaths from people eating, or not eating, but being in contact. It was a couple of years ago who was clearing his monkshood out of his garden, and he had lots of contact monkshood. I don't know if he ingested it at all, but he ended up dying of it. And also, talking about people eating things, there was my partner, he comes from Guernsey, and Guernsey was invaded in the Second World War by the Germans, and the Germans saw, because food was very short, they saw them eating a plant called Alexander, which is like grows by the sea. It's a sort of part of the carrot family. And they thought this was, they thought, oh, wait, we should do this as well. But they also common in Guernsey is the hemlock water dropwort, very similar to hemlock and very poisonous. And quite a lot of German soldiers actually died eating the hemlock water dropwort. Anyway, so that's a digression. Sorry.
No, that's fine, thank you. And that's all the questions. And so we'll pass you back to Helen. And apart from making me feel old with references to Germaline and walnut whip, that was wonderful. Thank you.
Well, I'm the same era, so yes, I've always remember my sort of mum and dad would occasionally, but I guess a walnut whip and sort of indulge themselves like a weekend cheese, so sort of. And Germaline, yes, whatever happened, you've got a dab with Germaline on it, and it has quite a nice smell, I think. Perhaps it's a bit Marmite-ish. You like it or you hate it. Anyway.
Yeah, I love the smoke-Germaline. I think it reminds a lot of people of being comforted by their parents. You've fallen over and cut your knee, and someone would come along with the Germaline. So I think that's why it has such nice associations. Ian, that was a wonderful talk. Absolutely fascinating tour through the history of medicine, with all those stopping points along the way, all those members of the great and good, the Queen Mother, Dwight Eisenhower, various others who along the course of the history of medicine have made kind of unexpected inputs into changing things in most ways for the better, I think. And I thought one very interesting fact that you mentioned at the very start, that only 10% of plants have undergone any investigation with a view to medicinal purposes. I think it kind of gives us hope that perhaps in the remaining 90, there may be some wonder drugs yet to be discovered. But I think something that you mentioned, which is the importance of inquisitiveness, is something that impressed itself very much on me listening to your talk, that these developments have required the kind of input of curious people who are prepared to put in the work, do the investigations, and figure out what it is that's going on with the mouldy hay or whatever it may be. I think that came across very, very clearly. So as Jeff mentioned, we've had a full house tonight, 100 people listening in, and I'm sure all of them will have enjoyed it just as much as I did. So thank you very much, Ian.
Okay.
It only remains for me to remind people about our next event. It's going to be the last one now before Christmas, so do make sure you come. It will be the 8th of December. It will be a joint event with Climate Action Ilkley and the Ilkley Clean Rivers Group. And we're very lucky to be hosting Professor Rick Batterby, and his talk is going to be entitled "Water in the Dales, Are We Keeping Up with Climate Change?" And I'm rather suspecting that the answer to that is going to be no, but perhaps no spoilers. No spoilers. I'm sorry, Rick, if I've given the game away there. So please do tune in on the 8th, same time, same place, and hope to see you then. Thank you. Good night, everybody. Have a good evening.